ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ಈ ವಿಡಿಯೋದಲ್ಲಿ ಸೆಂಟ್ರಲ್ ಡಿಫರೆನ್ಸಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಕೆ ಹೋಗ್ತಾ ಇದ್ದೀವಿ. ಸೊ ದಿಸ್ ಕಮ್ಸ್ ಅಂಡರ್ ಯೂನಿಟ್ 1. Before this we have studied the method of interpolation. Interpolation means given the values of x, x0, x1 and xn and the corresponding values of y, it is a process of finding the value of y corresponding to given value of x. ಈಗ x ಯಾವುದೋ ಒಂದು ವ್ಯಾಲ್ಯೂ ಕೊಟ್ಟಿರ್ತೀವಿ ಇಲ್ಲಿ. So corresponding to this x we have to find what is the corresponding functional value y. That is called interpolation. If this x lies outside x0 and xn, then the process itself is called extrapolation. Instead of interpolation, there we use the word extrapolation. Now here we treat x0 as the initial point and xn as the end point. That is for our reference. So if this is the case, you have x0, x1, xn in the order such that x0 being an initial point and xn being an end point, we apply Newton's forward interpolation formula and backward interpolation formula appropriately to interpolate the value of y. If the value of x is close to x0, then we prefer Newton's forward interpolation formula. If the value of x is close to xn, then we prefer Newton's backward interpolation formula. That what we have studied in the first half of the unit 1. Now under finite differences, the second part is about central differences, where the point x0 is treated as the middle point of the given set of independent values. So here instead of x0, x1, x2, xn, the given independent values are named as x minus n, x minus of n minus 1 and so on, x minus 2, x minus 1, x0, x1, xn. So this x0 is treated as the middle point of the table of independent values given. Now in this case, the given value of x, if it is close to end point x0 and xn, as I said, we have to use Newton's forward interpolation formula or backward interpolation formula. If the value of x is close to the central point, so what happens in this case? If the value of x is the center point, then you can use x0 or you can use Newton's forward interpolation formula or backward interpolation formula. That is no problem in that case. But the central difference is about, if the middle point is very much close to x, then how we can find the value of y in a efficient way. So that is about central differences. So the difference between the rest of the portion we have discussed, and this is in all the previous cases the points are treated like this, x0, x1 up to xn. In these cases, central differences, x0 is treated as the central value or point at the center of the given set of data. So that is the only difference. Next, central differences. What are the different formula we are going to apply? Here under central differences, we usually think of the problems wherein the value of x will be close to x0. Here there are two types of formula. Number one, Gauss forward formula. Gauss forward formula, and obviously the second one is Gauss backward formula. So Gauss forward formula, as usual, with the basic, given the point x minus n, x minus of n minus 1 and so on, x minus 1 comma x0 comma x1 xn, and the corresponding functional values y minus n, y minus of n minus 1 and so on, y minus 1, y naught, y1 and so on, yn. The value of y, these are equidistant. The value of y corresponding to, for given x, that is obviously close to x0, is given by y equal to y naught plus r into delta y naught. As usual, you have to construct the finite difference table. The advantage of this is in both the forward and backward formula, you have to construct only forward difference table. No need to worry about backward difference table. The formula is y equal to y naught plus r into delta y naught plus r into r minus 1 divided by 2 factorial into delta 2 y minus 1 plus r into r minus 1 into r plus 1 divided by 3 factorial into delta 3 y minus 1 plus r into r minus 1 into r plus 1 into r minus 2 divided by 4 factorial into delta 4 y minus 2 plus r into r minus 1 into r plus 1 into r minus 2 into r plus 2 divided by 5 factorial into delta 5 y minus 2 plus and so on. You can continue this formula. Next term will be obviously r into r minus 1 into r plus 1 into r minus 2 into r plus 2 into r minus 3. Other next term only r plus 3 add aಗುತ್ತೆ. So where r equal to x minus x naught plus h. This is Gauss forward interpolation formula. Next, Gauss backward interpolation formula. Gauss backward interpolation formula. So here also while writing the difference table, it is enough if you write only the forward interpolation table. No, not necessary to write the backward interpolation table. It is enough if you write forward interpolation table. The formula as usual with the same basic. Given x minus n, x minus of n minus 1, x naught and so on xn, which are equidistant values of x, and corresponding functional values be y minus n, y of minus y minus of n minus 1 and so on y naught yn. The value of y for a given value of x that is close to x naught is given by y equal to y naught plus r into delta y minus 1 plus r into ಅಲ್ಲಿ ಫಸ್ಟ್ ನೆಗೆಟಿವ್ ಬರ್ತಿತ್ತಲ್ವಾ r minus 1 ಬರ್ತಿತ್ತು ಇಲ್ಲಿ ಫಸ್ಟ್ ಪಾಸಿಟಿವ್ ಬರುತ್ತೆ r plus 1 divided by 2 factorial into delta 2 y minus 1 plus r into r plus 1 into ಆಮೇಲೆ ನೆಗೆಟಿವ್ r minus 1 divided by 3 factorial into delta 2 y minus 2. So ಇಲ್ಲಿ delta 2 ಹೋಗಿದಲ್ಲ delta 3 it is plus r into r plus 1 into r minus 1 into r plus 2 divided by 4 factorial into delta 4 y minus 2 plus r into r plus 1 into r minus 1 into r plus 2 into r minus 2 divided by 3 factorial 5 factorial it is 5 factorial delta 5 y minus 3 plus and so on, where r equal to x minus x naught by h. This is about Gauss forward and backward interpolation formula. While constructing the table, we'll get what happens. The finite difference table. Okay, I'll write it once. Finite difference table just to demonstrate. Finite difference table. You have to write the values of x here, the values of y. first forward difference, okay, delta y, second forward difference, third forward difference, and so on. So here I have to write x minus n plus 1, and so on, x minus 2, x minus 1, x naught, x1, x2, and so on. Similarly here y minus n plus 1, and so on, y minus 2, y minus 1, y naught, y1, y2, and so on. Obviously yn bandiruttalla. So in this way I have to write the values. Okay, next obviously the difference barutte. This is first note. Let us take this as note. This is first note I have to observe. Now this is okay, first note. Second note, suppose you have odd number of values, xn, x minus n plus 1, and so on, x naught, x n minus 1, x. Suppose there are odd number of values, then there is no problem in choosing this x naught. Middle point you get easily. If there are even number of values, there will be two middle values, right? Suppose you have values like this, x, okay, ikkade x naught irutte, x naught and beda. So 1 3 5 7 8. So 1 2 3 4 5. See, totally there are 5 values. So this you can choose as x naught. That you can choose as x naught. Then no problem if there are odd number of values. So suppose there are even number of values, then in case of Gauss forward formula, you have to take the first value as x naught. Suppose here I have 10. So these two are middle values. Howda? 1 2 3 4 5 6. There are 6 values for x. So there are two middle values. While applying Gauss forward formula, first of the two middle value is taken as x naught. So for Gauss forward, you have to choose this as x naught. First of the two middle value should be taken as x naught. If you are applying Gauss backward, then you have to choose this as x naught. This is for Gauss backward. So that is the second note. If there are odd number of values of x, then you can easily choose x naught. That is the middle one. If there are even number of values, there will be two middle values. So first of the middle value is taken as x naught in the case of Gauss forward formula, and second of the middle value is taken as x naught in the case of Gauss backward interpolation formula. So next, let us start with the problems. Number 1, given the data, so the values of x are 1 2 3 4 5, 1 2 3 4 5, and the corresponding functional values 5 17 46 97 176. Find y of 3.2. Find y of 3.2 using Gauss forward formula. Gauss forward formula. Solution. First you have to look into the values of x. How many values are there? There are 5 values. So given you have to write the values of x. Given the values of x as 1, 2, 3, 4 and 5. Choose x not equal to, so middle value, choose x not equal to 3. Then x1 will be 4, x2 will be 5, x minus 1 will be 2 and x minus 2 will be 1. Now construct the table. The finite difference table is the finite difference table is, to construct the table, the value of x here the value of y. So the values of x are 1, 2, 3, 4, 5 and the corresponding functional values 4, 17, 46, 4, 17, 46, 97, 176, 176. So the first differences are delta y, you have to write delta y 13, 29, 51, 79. Second differences 16, 22, 28. Third differences 6, 6. Fourth differences 0. So this is x naught, x minus 1, x minus 2, x1, x2 and corresponding to that this will be y naught, y1, y minus 1, y minus 2, y1, y2. Similarly, you need to identify all these entries. By Gauss forward formula, we have, write down the formula here, y equal to y naught plus r into delta y naught plus r into r minus 1 divided by 2 factorial into delta 2 y minus 1 plus r into r minus 1 into r plus 1 divided by 3 factorial into delta 3 y minus 1 and so on, where r equal to x minus x naught divided by h. So here x equal to 3.2, x naught is 3, therefore r equal to, okay, h is 1, right? Okay, h is 1, so r equal to 0.2. Substituting the values, we'll get y of 3.2 equal to 46 plus 0.2 into y naught delta y naught, it is this 51 plus 0.2 into 0.2 minus 1 divided by 2 into 22 plus 0.2 into 0.2 minus 1 into 0.2 minus, plus 1 plus 1 divided by 3 factorial andre 6 into 6. So this will be approximately 54.728. That is the required answer. Similarly, let us take one more. Use Gauss backward formula use Gauss backward formula to estimate population in 1936 given year population. It is given in thousands. So year 1901, so population is 12,000. 1911, 15,000. 1921, 20,000. 1931, 27,000. 1941, 39,000. 1951, 52,000. Solution. Here the values of x are 1901 to 1951. 1, 2, 3, 4, 5, 6. There are 6 values. The middle values are 1921 and 1931. Since we are applying Gauss backward interpolation formula, we have to choose second of the middle value as x naught. Solution. Here x naught equal to 1931. The difference table is construct the difference table here. The values of x in the first column, values of y in the second column, first differences, second differences, third differences. Now the values of values of x: 1901, 1911, 1921, 1931, 1941, 1951. Okay, write smaller. 1901, 1911, 1921, 1931, 1941, 1951. Y values 12, 15, 20, 27, 39, 52. Delta Y 3, 5, 7, 12, 13. 2, 2, 5, 1. Yeah, third differences are 0, 3, minus 4. Fourth difference is minus 0 minus 3, get minus 3. 3 minus of minus 4, you get 3 plus 4, 7. Fifth difference is minus 3, minus 7, minus 10. Now write down the formula by Gauss backward formula. Gauss backward formula, we have y equal to y naught plus r into delta y minus 1 plus r into r plus 1 divided by 2 factorial into delta 2 y minus 1 plus r into r plus 1 into r minus 1 divided by 3 factorial into delta 3y minus 2 plus r into r plus 1 into r minus 1 into r plus 2 divided by 4 factorial into delta 4y minus 2 plus r into r plus 1 into r minus 1 into r plus 2 into r minus 2 divided by 5 factorial into delta 5 y minus 3 plus and so on, where r equal to x minus x naught by h. It will be 0.5. Now substituting these values we get y approximately equal to, I'm not going to substitute the values here, just write the final value 32.34375. that is approximate population in the year 1936. So with this we have demonstrated or given 2 examples on Gauss forward and backward interpolation formula. Notes is given. Please practice few more problems on this as we have sort of time. I can't discuss all these problems here, so I will give you 2 problems as exercise. Okay, use Gauss forward interpolation formula. This is about interpolating polynomial. Use Gauss forward interpolation formula interpolation polynomial ಮೇಲೆ ನಾವು ಪ್ರಾಬ್ಲಮ್ ಸಾಲ್ವ್ ಮಾಡಿದ್ದೀವಿ ಪ್ರೀವಿಯಸ್ ಕೇಸಲ್ಲಿ. So try to apply same method here to find or to fit a polynomial. Given f of 0 equal to 3, f of 1 equal to 6, f of 2 equal to 11, f of 3 equal to 18, and f of 4 equal to 27. Hence find f of 1.5. So this is the actual problem. So the polynomial actually I have to get is f of x equal to x square plus 2x plus 3, and f of 1.5 is 8.25. So try to solve this one. Let us give one more problem. This is about forward interpolation, right? So same thing, apply Gauss backward interpolation formula. Apply Gauss backward interpolation formula. So Gauss backward formula to find u 3.8. To find u 3.8, given that u minus 2 equal to 5, u naught equal to 9, u2 equal to 21, u4 equal to 41. Here the values of x are minus 2, 0, 2, 4. See, there are 4 values, there are 2 middle values, out of which this will be x naught. because we are applying Gauss backward formula. Answer you have to get is U 3.8 equal to 38.64. Yes, with this we are going to wind up discussion on Gauss backward and forward interpolation formula.